All right, let's take a look at another variation of a quadratic reciprocal function. Okay, so we have f of x is equal to 1 over x squared minus 4x minus 12 minus 2. And actually, if we take a look at the denominator here, we can actually factor this. And you can actually see here, if we do the factoring, you can, two numbers that add up to negative 4 that multiply negative 12, you can write this as negative 6x plus 2x minus 12. And if you factor in x, you get x minus 6 plus 2x minus 6. You get x plus 2 times x minus 6. Okay, so this is our factored format of our function f of x. And the idea here is now we can actually notice that we have two restriction values of x on our domain. So that's what I'm going to take a look at in a second. So I'm just going to rewrite my expression in factored form. So you have 1 over x plus 2 times x minus 6 minus 2. Okay. So let's start with the domain. So starting with our domain x belongs to all real numbers. But here x cannot equal negative 2 or positive 6. Both of these values would make sure that the denominator here would be 0, right? Like f of negative 2 here would give you 1 over 0 minus 2, and this is undefined, right? Doesn't exist. And f of 6 here would give you 1 over 0 minus 2, and this also doesn't exist. Okay, so these are two restrictions on x. So you can notice how this is different from some of the previous examples we looked at. Let's take a look at the range here. The range is still going to be the same thing. So if we take a look at our fraction here, this portion here cannot equal 0 because of the fact that you can only make a fraction 0 if the numerator is 0. So 0 minus 2 doesn't happen. So y belongs to the set of all real numbers, but y cannot equal negative 2. Okay? So now that we have our domain and range, what we want to do next is we want to look at our asymptotes. So our vertical asymptote is the restriction on the domain, so x can be equal to negative 2 and 6, and our horizontal asymptote is the restriction on the range, in this case y is equal to negative 2. Okay, so we have our asymptotes. What I want to do now is I'm just going to create a generalized sketch with the asymptotes. So I'm just going to do that here. Alright, so here's our Cartesian plane, and what we want to do now is let's plot our vertical and horizontal asymptotes on this grid. So on our vertical asymptote here is negative 2, so I'm just going to do the vertical asymptotes in red. Okay, so it's negative 2, so this is one of our vertical asymptotes. The other vertical asymptote here is 6. So this value here. And we also have a horizontal asymptote at y is equal to negative 2. Okay, so let's do the horizontal asymptote in blue. So this is the horizontal asymptote in blue. So the horizontal asymptote, y is equal to negative 2. The vertical asymptote is basically x is equal to negative 2. And vertical asymptote x is equal to 6. Okay, so now that we have those 2 points, what we can do next is we can find our intercepts, right? So if we want to figure out our intercepts, I'm going to start by finding my x-intercept. So I'll just use yellow here. Okay, so let's solve for my x-intercept. If I want to solve for my x-intercept, I'm going to let f of x equal 0. So we get 1 over x plus 2 times x minus 6. Minus 2 is equal to 0. I'm going to move the 2 to the other side. So you get 1 over x plus 2 times x minus 6 is equal to positive 2. Now let's do the reciprocal here. So if we do the reciprocal, we get x plus 2 times x minus 6 is equal to 1/2, right? And what you could do at this point is you could expand this back to its original format, right? So we're going to do x squared minus 4x minus 12, and move the 1/2 to the other side. Minus 1/2 is equal to 0. You get x squared minus 4x minus, you can write this as 12.5 is equal to 0. So you can understand that because we've written our quadratic equation as ax squared plus bx plus c is equal to 0, you can actually solve for this using the quadratic formula. Okay, so recall that the quadratic formula, x is equal to negative b plus minus b squared minus 4ac over 2a. Okay, so I'm just going to kind of plug these values in and just kind of openly solve for this. I'm pretty sure all of you know how to do this, right? So you have negative 4 plus minus b squared, which is negative 4 squared, minus 4 times 1 times, so a is 1, and then c here is negative 12.5. Okay, and this is over 2 times 1. So if I plug this in, x is equal to, so if you crunch this out, x is equal to either 6.062 approximately, or approximately negative 2.062. Okay, so I'm just going to use these values, right? And these are just rounded values. So 6.062, let's say it's like somewhere here. So this is one of our x-intercepts, and the other intercept here is negative 2.062. So it's going to be to the left of the vertical asymptote, right? So we'll call this 6.062 and 0, and negative 2.062 and 0. Okay, so we have those points. And then what you want to do is create your sketch, right? So for your generating our sketch, we want to use the confines of the asymptotes. So if I'm creating the confines of the asymptotes, I'm going to do that this way. Okay, so this is one of our sketches of our graph. The other sketch of the graph is going to look like this, right? And we can also figure out the y-intercept of our function, right? The y-intercept will be a lot easier to find. So if we are trying to find our y-intercept, what we can do here is I'm going to let x equal 0. So if I let x equal 0, I'm going to do f of 0 is equal to, and I can use the original function. So if I plug in 0 for x, you get 1 over negative 12 minus 2, which is negative 1 over 12 minus 24 over 12, which is negative 25 over 12. Okay, so f of 0 is negative 25 over 12. So this is going to look like, it's a little bit more, a little bit less than negative 2. So this is like 0 and negative 25 over 12. Okay, it looks like that. And this is another point out. Basically, there is going to be, in these types of functions where you have two vertical asymptotes, there's going to be a parabola that's going to be located in this middle quadrant that is created by the asymptotes intersecting each other, right? So the way we can figure out the parabola has a vertex, and the x value of the vertex, and this is something that you want to remember, the x value of the vertex is the midpoint of the vertical asymptote. So you have vertical asymptote 1 plus vertical asymptote 2 divided by 2. So the first vertical asymptote here is negative 2. Second vertical asymptote is 6, and you divide this by 2, so you basically get 4 over 2, which is 2. So the x value of the vertex is 2. Once you have the x value of the vertex, you want to find the y value of the vertex. I'm going to do f of 2 and plug it into my original function. So if I plug in f of 2 into my original function, I'll just use the factored form. I'm doing 1 over 2 plus, I think our function here was 2 plus 2, 2 minus 6 minus 2, okay, which is basically 1 over 4 times negative 4, it's negative 16, minus 2 is basically 32 over 16, and this is basically negative 33 over 16. Okay, so f of 2 is negative 33 over 16, so the point here is 2 and negative 33 over 16. Okay, so this is going to tell us that, right, the x value of the vertex is here, and negative 33 over 16 is slightly above this value, so it's going to it's slightly below this value. So this is the vertex. Okay, so technically if we do a sketch here, I'll use a different color. Let's use green here. Okay, so if we do a sketch here, this is what the parabola will look like. Okay, so it is somewhat narrow. We are kind of just generating a sketch. This is what the parabola will look like. So this point here is the vertex, and the vertex is 2 and negative 33 over 16. Now we basically have an axis of symmetry that gets generated. Maybe we should use a different color. Let's use purple here. We get an axis of symmetry that gets generated at x is equal to 2. Okay, and this axis of symmetry actually creates two mirror images, right, that crosses the x value of the vertex. So the axis of symmetry, it actually creates a mirror image of the entire quadratic reciprocal function. So this is very interesting to kind of note. It actually creates a mirror image of the two halves of the graph. And you can notice that the sketch of this function is quite complex, right? And the last thing we can do here is we can assess the end behavior. Now the end behavior here is quite complex because there's going to be, we have to look at both asymptotes, right? Because of the fact that we have to look at the left and right side of the asymptotes. So let's take a look at the end behavior. Right, so these questions do take a little bit of time. Let's start by x approaching negative infinity. What happens to the function? Well, if we go this way on negative infinity, then we can notice that y actually approaches the horizontal asymptote, right? Y actually approaches negative 2 from above, right? So y approaches negative 2 from above. You can actually notice the same thing occurring as x approaches positive infinity. Y also approaches negative 2 from above, right? So if we were saying above, we should put a plus sign here. Okay, so this is negative 2 from above, and then what you want to do here is let's approach the vertical asymptote. I'm going to use a different color. You can approach the vertical asymptote from the left side of negative 2 and the right side of negative 2. So if I approach the vertical asymptote from the left side of negative 2, y actually approaches negative infinity. Right, and if I approach the vertical asymptote, positive infinity, we're looking at this portion. So it's positive infinity, right? Because we're basically, as we go this way, the graph goes upwards. And as we approach the vertical asymptote from the right side of negative 2, y approaches negative infinity because we're going this way, and then this graph, this trace is going downwards, right? So you're looking at the trace in green this time. We can also look at the other asymptote, 6, from the left side and the right side. So as x approaches 6 from the left side, y is actually going closer and closer to negative infinity. So y approaches negative infinity, and as x approaches 6 from the right side, right, y will basically approach positive infinity. That's what you see there. Okay, so you can notice that the end behavior is a lot more complex, and you actually have to test 6 different values. So this is the sketch of a quadratic reciprocal function with two vertical asymptotes. Okay, so it's very interesting.